Hi there. So we embark on our second section of this chapter. So if you think back to last section, we just talked about a sequence of numbers that went up or down by a common difference. Well, I said at the beginning of the last section that this chapter is about what's called sequences and series. And I want to explain the difference between those two things right now. So this lesson is all about what's called an arithmetic series. Last time was all about an arithmetic sequence. I want to show you the definition and then kind of explain the difference here. So an arithmetic series is the sum, meaning we're going to add numbers together, of the terms of an arithmetic sequence. Basically what we're going to be doing is, last class we had a sequence 1, 3, 5, 7. This is an arithmetic sequence, goes up by 2 every time. What a series does, a series replaces all the commas with plus signs. My Siri just went off. I'm not talking to you, Siri. That might get annoying. So here's my arithmetic sequence. If I wanted to talk about the arithmetic series, it would be 1 plus 3 plus 5 plus 7. And then when I add these four numbers together, 12 plus 4, I get 16. So a series is when we take the numbers in an arithmetic sequence and then we add them all together and we actually get a number in the end, a total. Okay. This too is going to have its own formula. So just like we had an arithmetic sequence formula, we're going to have an arithmetic series formula. And I'm going to show that to you right now. So if I want to find the first n terms of an arithmetic series, here's our formula. We're going to denote it as S sub n because now we're looking for the sum of n number of terms. So I could say find the sum of the first 10 terms or whatever. The sum equals however many terms we're adding together, so that's n, times the first term plus the last term, all divided by 2. So this is how we find the sum of an arithmetic sequence. We take however many we're adding, we add the first and last numbers together, multiply those, divide by 2. That's our formula. So a sub 1 stands for the first term, a sub n stands for the last term, n is how many terms we're adding, and then s sub n is the actual sum that we're looking for. And now we practice. Find the sum of the first 50 positive integers. The first 50 positive integers. So think about what we're doing. The first 50 positive integers, we want to add 1 plus 2 plus 3 plus ... all the way to the 50th number. I want to add these 50 numbers together. Okay, that's the question being asked here. Okay, well, I'm looking for the sum of 50 numbers. That's my notation. S sub 50. Well, in the formula, n, right here, is 50. This stands for how many numbers are we adding together. This is the first term. A sub 1 is the first term, so in this case, it's 1. Plus, a sub n is the last term. Now, here's where you need to be very careful. It's only, for this specific example, a lot of times n and a sub n will not be the same number. N stands for how many numbers we're adding. A sub n stands for the last number. Well, it just so happens the last number in this case is 50. So we're doing 1 plus 50. This is not going to be very common. Divided by 2. In my calculator, I get 1275. So if I would add all the numbers from 1 through 50 together, I would get 1,275. Example 2, find the sum of the first 10 odd integers. So now think about what we're finding. We're finding the first 10 odd. So 1 plus 3 plus 5, 7, 9, 11. What's that? 1, 2, 3, 4, 5, 6. There's the 7th, 8th, 9th, 10th. So this is asking us to add these numbers together. Now, obviously, we could just take our calculator and just add these numbers together and get a total. But I want to practice using our formula because a lot of times I'm not going to give you a case where you can just sit here and add these numbers together. I might say find the sum of the first, 1,000 odd integers. And we'll have to talk about what we do if I ask you to do that, okay? If you look at the next one, it says find the sum of the first 60. So a lot of times you're not going to want to take your calculator out and add those numbers together. So let's use the formula. So we are finding the sum of 10 numbers. Well, n in the formula is 10. That's how many numbers we're adding. We're going to add 10 numbers together. The first one is 1. And then the last one is right here, 19. So notice in the last one I said it's going to be rare that these numbers are the same. That just goes to show you right there. Divided by 2. So 10 over 2 is 5 times 20, you get 100. So if I add those 10 numbers together, I would get 100. All right. I would, again, encourage you to pause and try example 3. I think this is good practice instead of just me sitting here showing you what to do. I would try it and then see what you come up with. And then unpause the video and go. Okay. Find the sum of the first 60 terms in which the first term is 15 and it's going up by 80 every single time. So that means, oh man, what would it be? So we're doing 15 plus, the next one will be 95. The next one will be 175. So you could sit here and do this and figure out all 60 numbers and then add those 60 numbers together. Or we can use our arithmetic series formula. Okay, so we're looking for the sum of 60 terms. We know the first term is 15. I lied. Poop. That should be, that first one is n, so that should be 60. My bad. We know the first term in the formula. So the first term is 15. Plus, now here is where things get interesting. I don't know what the last term in this sequence is. I don't know the 60th number, right? I don't know what this is. I'm looking for the 60th number. I don't know what it is. I mentioned, in the last lesson how when you guys are using these formulas, if you're ever solving or using a formula, there better only ever be one thing you don't know in that formula. Otherwise, you can't solve it. Like, I don't know 2 things here. Well, this is going to be very common in this section, right? What you're going to have to be doing is essentially a system, but I don't want to think about it like a system. We have a way to find this number. A lot of times with arithmetic sequence and series problems, you're going to have to use the 2 formulas you know within one problem. Like, we're adding numbers together, but I don't know the 60th term. Well, that's what this formula from last class did for us. This formula from last class would find you a specific term in a sequence. So a lot of times if you're solving a series and you don't know something, typically you have to go to the sequence formula to find what you're missing and then plug it in. So it is kind of like you're doing a system. You have 2 different formulas you know, we're solving it. So I don't know the 60th term. If I did, I'd plug it in here, calculate this, and I got my answer. So let's look for the 60th term in this sequence. I know the first term's 15. I know it's going up by 80. And n, the number of terms, is 60. I'm looking for the 60th term. And then I can just enter that in my calculator. This is 4,735. Now be careful, that's not the answer. That is, if I would extend this sequence right here out to the 60th number, that would be the last number that I'm adding. And the question's asking me to add all these numbers together. So be careful. A lot of times I'll have students that will do this, think that's the answer, and then they just stop. That's just the last number. So I'm going to plug that where this is right here. So in my calculator, I just have to do 60 times whatever 15 plus 4735 is, divided by 2. And we get 142,500. But the reason I wanted you to try this one on your own is to see if you would do the correct thing when you got stuck. But this is pretty common. If you're solving and you get stuck, a lot of times you have to jump over to the other formula and use it to find whatever you're missing. All right. Example 4. Find the first three terms of an arithmetic series in which the first term is 5, the last term is 100, and if I add all the numbers together, I get 1050. So I'm looking for the first three numbers that make that happen. Well, a lot of times when I jump into these problems, I don't know where to go. I'll be honest with you. And so I just start taking my formulas and plugging in what I know and see if good things happen. Let me explain what I mean by that. I have this new formula for arithmetic series. Let's take what we know and see if I can find any information from this. Well, I know S sub n is 1050. They tell me that. I don't know n in here. It doesn't tell me how many terms. I know the first term is 5. I know the last term is 100 divided by 2. So I didn't know exactly where I was heading, but now I have this equation that at least now I could figure out how many numbers we were adding to get this sum. Now that's not going to answer the question, but that's going to help us here soon. So if I solve this, let's see, multiply both sides by 2. So 2100 equals 105 times n. I get n to be 20. Again, that doesn't answer the question, but let's think about how we can use that. You know, when it said find the first three terms, I knew the first term. If I knew the difference, like if I knew what this sequence was going up by each time, I could answer the question, right? Like if I knew the sequence was going up by 2 each time, I would know it'd be 5, 7, 9, and I'd be done. So I'm really, to answering this question, I'm trying to find D, the common difference. There's no D in this formula right here, but there is in the arithmetic sequence formula. Well, let's see now if I can jump over to this formula and see what I got. Well, I know A sub n is 100. They tell me that. I know the first term's 5. I don't know the common difference. That's what I'm after. But now, from using that first formula, I know n is 20. I know I was adding 20 numbers together. So plug 20 in for n. We get 19. So now we can solve this for the common difference. Subtract 5. So 95 divided by 19 is 5. So that means I have some sequence where it starts at 5 and it's going up by 5. So I know my first three terms are 5, 10, and 15. And if I did that all the way up to 100, the whole point is if I added all these numbers together, I would get that sum. But the 5, 10, 15, that's the answer. We always got to make sure we're answering the question, which is tough for students in this chapter. That's a common mistake is you'll find info, but then a lot of students won't answer the question. Always make sure you reread the question, make sure you answered it. There we go. All right. The next stuff is a little different. It's new notation, and it's notation that can look a little scary, but I'm going to try to get you to understand this as best I can through this video, okay? So this new notation is called summation notation. This Greek letter right here stands for sigma. This is a sigma symbol, and I want to explain what this problem is telling you to do. I want to explain what a sigma symbol does. Anytime you see sigma, it is a command to you. This symbol is saying, hey, I want you to add numbers together. That's what it's requesting. It's requesting you to add numbers together and get a sum. So you being the person getting the command to add numbers together, my hope would be you would ask, okay, how many numbers, Mr. Sigma, do you want me to add? And what numbers do you want me to add? Right? All it's saying is add numbers. And then you got to figure out what numbers to add. Well, that's what all this other stuff around the sigma is going to help you figure out. It's going to help you figure out how many numbers you're actually adding. Okay? So let me explain, let me show you. This right here is kind of like a counting mechanism. And here's what I mean. If I want to figure out the first number that Mr. Sigma wants me to add, I take whatever this bottom number is. This is called the index right here. I take whatever this bottom number is. In this case, it's a 1. It doesn't have to be. If you look here, it starts at a 6. It can start at any number at once. But I take whatever that number is, and I plug it in to this expression right here. This expression will be used to figure out the numbers we're adding together. So I plug 1 in for n, and I get 2. 2 is the very first number Mr. Sigma wants us to add. Then what I do is, again, this is kind of like a counting mechanism. I'm going to plug in every integer from this number, 1, all the way up to 10 into this expression to get the numbers that I want to add. So if I plug 1 in for n, now I plug 2 in for n, and then I plug 3 in and 4 in, all the way up to plugging 10 in for n to get all the numbers that I want to add. So the first number is 2, then I plug 2 in for n, and I get 4. Then I plug 3 in for n, and 4 in for n, all the way till I plug the top number in for n. If I plug 10 in for n, I get 20. So sigma was wanting us to add 2, 4, 6, 8, all the way up to 20. Okay? That's what it was wanting us to do. So think about how many numbers we're adding. This is kind of a big thing. We could take our calculator. This is an example where we could take our calculator and literally do 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20, get an answer, and that's our answer, right? But what if this number, that top number, like in this case, goes up to 140? Well, now we're not going to want to do that in our calculator. So we are a lot of times going to have to be using this formula right here. We're not going to on this particular problem. But I want to explain, you want to think about a couple of things. You're going to have to know the first term, which you find by plugging this bottom number in for n. You're going to need to know the last term by plugging the top number in for n. So in this case, that would be 20. You're also going to need to know how many numbers you're adding together. A misconception by students, they look at this top number and think, oh, this is how many numbers I'm adding. Well, that's not the case every single time, okay? The way you figure out how many numbers you're adding is you take the difference, you subtract these two numbers, and then add 1 to account for the bottom number. I'm basically doing from 1 to 10, so in this case it is 10. But on this problem here, we would not be adding 140 numbers together, because we would be starting with 6, right? 6, 7, 8, 9, all the way up to 140. So I subtract these two numbers right here, and that would be 134. But then we have to account for the first number. So we have to add 1 back, and we get 135. It's kind of like if I assign numbers 1 through 10 on the homework, right? If I assign 1 through 10 on the homework, you don't have 9 homework problems, you have 10 homework problems. Because 10 minus 1 is 9, but then you have to add 1 to account for the first number. That's the idea here. But anyway, if you added those together, you'd get 110. This next one says, write out the notation. So I want to figure out what numbers is this asking me to add. Mr. Sigma is telling me to add numbers together. So I take whatever this first number is, I plug it into the expression. So 3 plus 7, I get 10. 10 is the first number we're going to add. Then I'm going to plug 2 in for I, and 3, and 4, and 5, all the way to plugging 6 in for I. So if I plug 2 in for I get 13. Then plug 3 in for I. 9 plus 7 is 16. You see a pattern. It's going up by 3 each time, which makes sense because that's kind of like our slope right here. So we get 19, 22. So I was plugging in 1, 2, 3, 4, 5. Then plug 6 in. We get 25. And then it says just find the sum. So add those numbers together in your calculator and you get 105. That's the general idea. So example 6, which I've alluded to a little bit already, says find the sum. Again, you're not going to want to plug in 6, then 7, then 8, then 9, all the way to plugging in 140, and then adding all those numbers together. You're just not going to want to. So you might want to start by at least plugging in a few things. You know, if I plug 6 in for I get 15. That at least tells me the first number I'm adding. Maybe plug in another one. If I plug 7 in, 14 plus 3, I get 17. So it is going up by 2 each time, as it should. We see that right here by what that slope is. all the way to the last number we'd be adding, we plug 140 in for I, and that gives us 283. This is what we want to add and find the sum of. But I don't, in my calculator, want to do 15 plus 17 plus 19 plus 21. I don't want to do that all the way up to 283. Well, this is an arithmetic series. We're adding numbers together, and it's going up by 2 every time. That means we can use our formula. Well, we first need to figure out how many numbers are we adding. I already talked about this, but a very common wrong thing, there's 2 wrong things students do. First thing is, they go, oh, 140, wrong. And then they subtract 140 and 6 and say, oh, 134, wrong. You have to subtract these and then add 1, and you get 135. So you're adding 135 numbers together. The first one's 15. The last one is this, 283. And then divided by 2. And then you enter that, and you get 20,115 for your sum. All right. Well, sometimes it's going to want you to go the other direction. It wants you to go backwards. It says, write the following series in sigma notation. So basically, I want to go in the reverse order. My answer is going to look like this now. I want to write this series as a sigma notation problem or summation notation. So the first thing you're going to do is write the sigma. Okay. You get to pick what letter you want to use. You can use N or I. That's up to you. The reason they use I, this is not an imaginary number, but this stands for the index of the sigma. So sometimes they'll use an I there. A lot of times you'll see an N. N is usually the most common one that they use. So I'm going to use an N. My advice to you, always start with N equals 1. Even though a problem can be given to you starting anywhere, if you want to make this as easy on yourself as possible, start with 1. Trust me. Just please trust me. Always write N equals 1. Because if you start with 1 here, then the top number is however many numbers you're adding together, always. So if you start with 1, now if I'm adding 1, 2, 3, 4, 5 numbers together, the top number is 5. So that's pretty straightforward. We just start with 1, you start with 1, and then your top number is however many numbers you're adding. So we're done with that part. We just need to figure out the expression here that will give us these numbers. Now there's a couple different ways you could do it. We need to figure out what expression would I write here that if I plug in 1 to it, I get 9. And what a lot of students might do, they might say, oh, n plus 8. Don't write this. Because if I plug 1 in for n, I get 9. Well, also, if I plug 2 in for n, I have to get the second term. If I plug 2 in for n here, I get 10, not 11. So that's wrong. Here's how we figure out what to put inside of there. Okay? If you think back to last section, there was 1 or 2 problems where you guys had to write the explicit formula for a sequence, right? Where we had to come up with a formula that would find any numbered term in the sequence. And remember what we did? We just replaced the first term and the common difference. And that's what you're going to do on these problems here. If I want to figure out the formula, now we're going to kind of ignore this part, but we just need the first term, so 9. It's going up by 2 each time, so 2. And then we don't replace anything with 1. This is it right here. So that would be 2n minus 2. So 2n plus 7. And we could check it. If I plug 1 in for n, I should get 9. I do. If I plug 2 in for n, I should get 11. We do. And you could check the rest. Now, some people don't think of it this way. This will work every single time. Some people like to play around with the numbers. Like I mentioned a couple of times up here how since this was 3i, we knew it was going to be going up by 3 every time. Since this was 2i, we knew it was going to go up by 2 each time. So that number in front of your letter is what your common difference is. So like another way you could do this, since this is going up by 2 each time, we know it's going to be 2n. It has to be. 2 is what it's going up by. And then we just need to ask ourselves, if I would plug 1 in, I have to get 9. So how do I adjust this to get 9? Well, I would have to add 7 to make that happen. So that's kind of the thinking way. And this is the concrete algebraic way over here. But there it is. This is our sigma notation that represents that series. All right, last one. An auditorium has 50 rows. This is a very common question with series. An auditorium has 50 rows of seats. The first row has 14 seats. The second row has 16. The third row has 18, and so on. How many seats are there in the auditorium? So it goes 14, then 16, then 18. Think about what we're doing. We're adding the first row to the second row to the third row to however many is in that very last row. In this case, the 50th row. Okay, well, let's start with our sum formula. Since we're adding things together, we're adding 50 numbers together. So n is 50. The first term's 14. I need the last term. Well, this has come up before. If you're missing something, go to the arithmetic sequence formula. I need to find the 50th term in this sequence. The first term's 14. It's going up by 2 each time. And I know n is 50. So this is going to find how many seats are in the 50th row. That doesn't answer the question, but it will get us to the answer. So if I do this in my calculator, I get 112. A lot of students will put this as their final answer. That's not the final answer. That's just how many seats are in the 50th row. I want to know how many seats are there total. So we still have to finish this off right here. So plug 112 here. And now we can use our calculator. There's 3,150 seats. All right, again, try the assignment. If you have any questions, please do not hesitate to ask.